Hey everybody, welcome back to the hot tub build. So in this video we're going to be talking about two things: the pump house preparation and the plumbing that runs between the pump house and the hot tub itself. So let's take a look at the hot tub site here. Behind the house there's a deck, and the hot tub's located on that deck right about here. And if you follow the deck behind the master bedroom area over here, we've located a small, it's about 4 by 5 foot pump house. And inside the pump house, of course, there's going to be all the pumps and electronics and heater and stuff that's going to be used to power the hot tub. Between the two sites, there's a trench that contains the plumbing for the jet water and the recirculation water, as well as the power to the LED lights and a control line. And the trench also has the supply power from the house, but it splits off under the deck and joins the house at the panels. As I mentioned in the first video, the supply and return lines for the hot tub water are made of an inner and outer pipe. Here is how this is formed. The Y allows the circulation water to flow around the inner jet water pipe. That way, when the jets are off and this water is static, it is prevented from freezing by the warm flowing circulation water. This is the return pipe assembly receiving its pressure test. The first time I built this, one of the internal couplings failed and blew the whole pipe off in the trench. Second time around, I built it outside of the trench and pressure tested it for leaks. I filled it with water, so it's not just air, which can be quite dangerous if it were to fail. The other thing I wanted to pressure test were the 60-degree elbows. All the plumbing that's used on the hot tub is Schedule 40 pressure-rated PVC. However, to get a 2-inch 60-degree Schedule 40 elbow was something like $65 each. The standard 60-degree elbows that you might find at Home Depot are Schedule 40 DWV, drain waste vent, which is not pressure-rated. Even though all of this was going to be encased in concrete, for peace of mind, we decided to do a test for the holding capacity of these elbows. All right, here's the test setup. We got 2 elbows. One is submerged. The chamber's filled with water. And the other elbow is sticking out of the bucket. We have a pressure regulator and a valve there. And we're equalizing the temperature in the water in the bucket and in the chamber to 115. Which is about 11 degrees above the total hot tub temperature. And once this equalizes a little bit, we will test it at different pressure levels. I took it up to nearly 140 psi and left it all day. There were no leaks, there were no ruptures, so these elbows are good to go for our jet system. Unfortunately, I didn't take any good video of the pump house excavation. Here it is excavated and the drain pipes are installed to take away any roof runoff and meltwater that falls behind the pump house. Once the drain pipes are in, we roughed out the formwork and prepared to lay down the piping. The water pipes are encased in a 1-inch rigid foam insulation box and then wrapped in a vapor barrier. And here the assembly is sunk into the trench connecting the hot tub site and the pump house site, and you can see both the jet and circulation supply and return lines sticking up. But those manifolds on the top aren't related to the build, they're just there for pressure testing and holding the pipes in the right orientation. A base of gravel was laid down and compacted to a partial thickness, and then the electrical conduit was roughed in. At this point I decided to put a floor drain in the pump house to take away any spills from filter changes, which is that black ABS pipe in the center of the frame. On the left behind the PVC pipes are the power supply conduit, and along the back are the control and light conduits. That copper wire you see is a bonding wire that ties all the equipment together with the hot tub to prevent shocks. More about that later. The whole outer form and ground were sealed with a vapor barrier, which will be trimmed away from any exposed areas after we backfill it. Then I laid down a rebar grid and tied that into the anchor bolts, which is held by those little yellow brackets to hold this, which will hold the sill plate for the shed enclosure once we built that. Then we began to rough out the inner form. This pump house foundation will be poured as a monopore, so the stem wall forms float above the slab. The bonding wire ties into the rebar and then runs up a conduit into the pump house, and this same wire will run to the hot tub and tie into the whole hot tub rebar grid and a bonding pipe. This will ensure that the hot tub water, the deck, the basin, and all the equipment is grounded at the same voltage potential. We don't want any people getting electrocuted. That would kill the party. The last step of preparing the pump house for pouring was to build reinforcing structure around the form wood to prevent any bulging or shifting during the pour. Finally, I ran the rest of the conduit and pipes to the tub, splitting off the electrical supply to run under the deck and be joined up to the panels. If you're curious why there are 2 supply conduits, check out our first build video with more details on the electrical system, but in a nutshell, we have a main supply and a generator backup for critical systems as a failsafe. Alright, I hope you enjoyed the pump house prep. Next up, it's back to the main site to prepare the hot tub. Thanks for watching.